Today we're going to be talking specifically about units that we use for measuring in chemistry class and in science in general, as well as some common prefixes that we use to designate powers of 10 for those measurements and units, and then a quick introduction to how we solve problems through using an example of converting from one unit to another. So it's important to know that in science, no matter what country you are in, we use the same units. And that's so that we can easily communicate throughout the scientific community as to exactly what the data we're collecting is and what it means. So we call those SI units, and those units are meters for distance, liters for volume, atmospheres for pressure, usually degrees Celsius for temperature, although we will talk about another common scale used in chemistry as well, and grams for mass. And these are really the foundation for all of the types of data you will be collecting. And so if you don't know what these units are, now is the time really to become familiar with them. You might be more familiar with things like pounds for measuring weight. And in chemistry, we're going to keep referring to, instead of weight, we're going to call it mass. And that's because weight is actually a measurement of force. And when you take physics, we'll talk all about that. But for now, just suffice to say that when you think of weighing something, you're actually going to be recording the measurement mass, and we're going to use grams for that. Now we know that we can have measurements that are very, very big and measurements that are very, very small. And sometimes it helps to be able to describe those measurements instead of using powers of 10, actually using a prefix that's going to change our unit directly. And we have many of them. They are listed on page 10 of your AP Chemistry book. However, there are a few that you should really just kind of know. And the three that I'm going to give you today that I'm going to expect you to know are K for kilo, M for milli, and this Greek letter called a mu. It looks kind of like a U with a funky tail on the front, and that stands for micro. So if we put a K in front of one of our standard SI units, that's going to mean that unit times 1,000. So 1 kilogram is actually 1,000 grams. 1 kilojoule would be 1,000 joules. So as you see, we can put that prefix in front of any unit that we're using to measure, and it will mean the same thing. Same with lowercase m for milli. If we put lowercase m in front of the symbol for liter, now we're talking about a milliliter, which is actually 1/1000th of a liter. So it takes 1,000 milliliters to equal 1 liter. And finally, our micro. If we put a micro in front of any unit, in this case I'm using meters for distance, if we have a micrometer or a micrometer, that's going to be 1/1,000,000th of that unit. And you may have seen that term if you were in AP Bio last year, because when we're looking at cells and we're measuring things in cells, we often are using micrometers or nanometers to tell us how big that is. We're talking about 1/1,000,000th or 1/1,000,000,000th of a meter size, so incredibly small. And with these prefixes, we know that we can also set up what's called an equality or a conversion factor. So one term that you're pretty familiar with, I'm sure, is a centimeter. And you know there are 100 centimeters in 1 meter. Now, with this equality, I'm going to always refer to something like this as an equality because we have one thing equal to another thing. Sometimes it can be a whole string of things where each individual item in that length will be equal to each other. So I will call these kinds of things equalities. So in this specific equality, we have 1 meter is equal to 100 centimeters. And I can actually take equalities and I can do this little trick where I'm actually turning this into a fraction. And I'm going to call this kind of thing a conversion factor, because when I make this, I am going to be doing it specifically when I want to convert between different units of things. So if I want to know how many centimeters are in 2 meters, we can do that sort of mental math pretty easily. But what if I said how many meters are 2.54321 centimeters? That might be a little more difficult. So because we want to be able to do conversions for all kinds of numbers, I'm going to show you how to do that using some equalities and turning them into these conversion factors. The reason why this is a conversion factor is because if the top of my fraction or the numerator is equal to the bottom of my fraction or the denominator, I know that that entire fraction as a whole is simply equal to 1. It's like putting 5 over 5 or 25 over 25. We know that when you have something in the numerator equal to the same thing in the denominator, this whole thing becomes 1. And we can multiply anything by the number 1 without changing its actual magnitude or amount of stuff that is in that particular measurement. So depending on which direction I would want to go, whether I wanted to cancel centimeters and end up with meters, if that were the case, I would use this first conversion factor. But if, on the other hand, I wanted to cancel meters and end up with centimeters, I would use the second conversion factor. So let's go ahead and do a little bit of practice. Okay, so here I have a whole series of different conversion factors listed up at the top, and I want to know how many inches are in a kilometer. So keep in mind that we can turn any single one of these equalities into a conversion factor, and you can use that to answer this question. So I'm going to ask you right now to go ahead and pause the video, and I want you to try this for yourself, okay? All right, I'm going to assume that you paused it and you tried, at least attempted, and now let me go ahead and explain to you how I would do this. So if I want to know how many inches are in a kilometer, the first thing I want to do when I'm solving a problem is figure out what it is I know and where I want to go. Then I can figure out the steps in between. Okay, for now I know that I want to get to kilometers. So I'm actually going to put kilometer. I know I want to get inches. I have kilometers. So I'm going to write inches over here in my final answer. I know that that's the direction I'm going. And I also know that I'm starting with 1 kilometer. So I can put that right here. And I know somehow in between all of this, I need to get rid of kilometers and end up with inches. So there are a lot of different directions you could have taken. I gave you plenty of different equalities to turn into conversion factors so that you would have multiple ways of getting there. But let's see. If I go kilometers, I'm starting with kilometers, so I'm looking at these conversion factors both have kilometers in them. So you could have chosen either one. I'm actually going to work with this one and say times 1,000 meters over 1 kilometer. And you say, well, how did you know that you wanted to put kilometers on the bottom and meters on the top? Well, I want these actual units to cancel out. So I know that I needed the unit kilometers in the denominator so that that would cancel. Okay, now I have meters, but I still need to get to inches. So how am I going to get there? Well, let me check up here for where I have meters. I have meters, well, I just got them from here. I also have meters here, and this will go from meters to centimeters, and then I look at this equality and I can go from centimeters to inches. So meters to centimeters, I put my centimeters on top, I put my 1 meter on the bottom. Okay, now my meters will cancel out. I have centimeters, and I've got one more conversion factor I need to use where I'm putting centimeters on the bottom and inches on the top. Okay, my centimeters are going to cancel. I see that the unit I end up with is exactly what I wanted, and then I can actually go through and plug all of this into my calculator. So remember, anything that's on top of a fraction you're going to multiply. Anything that's in the denominator you would divide by. So I get 1,000 times 100 divided by 2.54, and that'll give you an answer. And I'm going to trust that you can actually plug them into your calculator and get that. What is the other way we could have done this, just setting it up with conversion factors? Well, instead I could have started with my 1 kilometer, and if instead of going straight to meters I converted to miles, I could have said 1 mile over 1.6 kilometers. Kilometers cancel. Then I have miles. I'm still trying to get to inches though. Here I've got a conversion that goes miles to feet. I can put 1 mile on the bottom, 5,280 feet on top. Miles cancel. Now I have feet, still trying to get to inches. And over here, this is my conversion for feet to inches. And so now I go 12 inches in 1 foot, and feet cancel out. And then when I plug that into a calculator, I will get a number that actually should be the same as the first one, even though it was a different method of getting there. 1 divided by 1.6 times 5,280 times 12 would give me my number of inches in 1 kilometer. And so that is how we set up a unit conversion kind of problem. It seems silly, especially because there are conversions available online all the time. All you have to do is type in how many inches are in a kilometer. You get an app that pops right up, and then you'd be able to plug in whatever your numbers are that you're trying to convert. However, you are not always going to have access to that, and we're actually going to find that there are specific conversions where we're looking at numbers of particles, where we're using the same kind of process for solving those problems, and those are also things that there aren't apps to be able to do because it will vary from problem to problem. So if you can master this kind of setup, then you're going to be able to master what we call stoichiometry in chemistry later on, which really has to do with predicting amounts of products and how many reactants we're using and that sort of thing. So being able to do this is really important, even though being able to convert from unit to unit doesn't seem like it's important. Okay, and so I'm going to leave you with a question so that you can get to practice that. And my question for you is, I want to know how many seconds are in 1 day. Okay, so that I want you to figure out, and I want you to send me that answer on Remind. I will know that you will have watched this because you will have done it. And I want you to be able to explain which conversion factors you were using. Don't just Google how many seconds are in 1 day. Actually challenge yourself to be able to do that calculation and see what you come up with. All right, thanks.